Schrödinger science dummies, it's only Mickey Dinger. We have a caller with a science question.
Can we extinguish the sun with a giant bucket of water?
And now over to our science expert.
Hello again, it's me, Professor Feltman. So we have an interesting thought experiment entitled, Can we put out the sun with a ginormous bucket of water? Screen! Meet Colin.
Hi, I'm the sun, but you can call me Colin. Just a
Okay,
moment.
turn his mic off, he can go on a bit. Colin resides in our solar system, our main star, which gives us light, heat and energy. Colin's on the large side, about 100 times more larger than the Earth, so you need a big bucket. And in order to get a bucket to him, this hypothetical bucket would have to carry more water than is available on Earth. And the water would freeze in the coldness of space, not to mention the distance of getting said bucket to Colin. Okay, so let's simplify. Let's take Colin out of our solar system and put him in our studio. Calm down, Granny, it's only a thought experiment. In order to extinguish the sun, we need to define what it is and what it isn't. Extinguishing the sun with a large bucket of water is like treating the sun like a fire. The sun is most certainly not on fire, for a fire is the visible effect of the process of combustion, a special type of chemical reaction. It occurs between oxygen in the air and some sort of fuel. Pouring water on the fire forms a thin layer of water around the burning object. As a result, the oxygen in the air cannot reach the burning object, and the object, hence, cannot burn any further. Pouring water over the sun won't have the same effect that you would think, because the sun doesn't react with oxygen, and there is no oxygen in space. The sun isn't burning at all. The sun isn't fire, but something far more powerful. The sun is powered by nuclear fusion, which is a process in which hydrogen atoms merge together to form helium, and as a byproduct emits a huge amount of energy. As a result, it shoots out protons and highly energetic particles that absorb the energy emitted from fusion, along with tons and tons of harmful radiation. From X-rays to radio waves, the sun is so harsh that even if you are 140 million kilometers away and you don't have the protection of Earth's atmosphere, the ozone layer to be specific, or a spacesuit, you will be fried within seconds by the sun's UV ray. There's a more effective way to get water to our sun than just using our bucket. There's an exoplanet only 40 light years away, made of water ice, called GJ1214b. It's a water world, which is 6 times the mass of the Earth. Pouring water on the sun will not extinguish it, because the amount of energy being emitted will almost instantly break the water's molecules into hydrogen atoms and oxygen atoms. And don't you forget, hydrogen is the fuel on which the sun runs, and a big bucket of water or an exoplanet will contain lots and lots of hydrogen. So instead of extinguishing it, you're adding more fuel to it. The sun will burn more ferociously. The sun has double the mass and double the fuel. But if you're playing the long game of extinguishing by throwing water, mass at the sun, you're not increasing its lifespan, you're reducing it. This is because smaller stars with less mass stay convective and thus live longer, while more massive stars go through their life cycle much faster and build up layers similar to an onion. Very massive ones may only live a few million years. However, that's not what you wanted, right? You wanted to destroy the sun completely. There is actually one way to do it, but it would require the same ridiculous amount of water that we proposed using before. This time, however, we would have to rev up the same water and hurl it straight into the sun at nearly the speed of light. This won't extinguish anything, no, but it would certainly challenge the gravitational integrity of the sun. This would cause the sun to break apart and be practically destroyed. Are you happy now? If you ask me, and everybody does, I would do away with the water, the buckets, and just use magnets. Let me explain. Hydrogen is weakly magnetic. If you expose the sun to a strong enough magnetic field, you could possibly blow it out by stripping away the outer layers of fuel and reducing the mass. Then the fusion at the core may possibly stop as the pressure reduces. But even I don't have a magnet that strong. You'd need the biggest solenoid coil in the universe to go around the sun.
Well, it's time for bed. I will see you tomorrow. If you've liked this video, why not show your appreciation by hitting like and subscribing? And if you have any questions or suggestions for future videos, let the people at Bratz HQ know in the comments below. Thanks for watching and good night.